All right, this is going to be a video talking about the transformation of functions, and it's going to be examples of how they can affect different functions already. So assuming you've watched a video or learned about parent functions already, again, this is not the first talk about transformations, so you may want to watch more of an intro video first. But this one's going to talk about how can we use these ideas to quickly graph or quickly identify parts of larger functions. So you'll notice the directions up top. Identify the parent function, identify the transformation from the parent function essentially, and then also make a graph. And then down at the bottom, we're also going to talk a little bit about what we call function notation to write the function in terms of the parent function. And I'll show you that's a pretty quick and simple process once we've done these other parts. So the first thing that I want to notice about g of x up top here is that the most important part, I've got an x squared and a minus 4, but the thing that governs the shape, the thing that's going to govern what we look like, is going to be that x squared. That's going to be sort of the more powerful part, if you will, pun intended. So we know it's going to be a parabola, and we know that because its parent function, f of x as we'll call it, would be just x squared. So you'll notice this is f of x already graphed on our graph here. The transformation is more the minus 4. Because it's happening after the x squared, we know that it's going to be a vertical effect, right? It's going to affect our y coordinates. X has already been squared. X is sort of out of the picture. But now I'm going to take all of those answers, all those red dots that I already have on my graph, and I'm going to subtract 4. So I'm going to shift, right? Subtraction is always a shift, but I'm going to vertically shift down 4 units. So what I would do is go down to my graph then. Instead of 0, 0, I'm going to go down to negative 4. So 0, negative 4. 1, 1 is going to become 0, 1, sorry, negative 3. 2, 4, again going down 4 units, takes us back down to 0 for the y coordinate. And the same thing happens with the negatives. Negative 1, negative 3, and negative 2 goes again from 4 down to 0. And basically we get a parabola traveling. And sorry, that one was a little squiggly there, so I'm going to try it again. See if I can make it look just a little bit better. Again, parabola traveling in the same direction, still going upwards. The only difference is all of the actual values, the y values, have been shifted down 4 units. And again, that happened because it was happening outside, right? After I squared, it was happening outside of my function. If I had to picture where the parentheses were, again, my squaring is going to happen first. I'm going to get my parabola. Then I'm going to move it down 4 units. Now, the last part of this, as I mentioned, is really just to write this in function notation, because f of x is x squared, and g of x is x squared, or essentially f of x minus 4, then what we can say is that g of x is equal to f of x, right, my original red parabola, minus 4. That's all there really is to writing it in sort of terms of f of x, or in function notation, right, in terms of my parent function. So let's try that over here at the right as well. Let's take a good look. First of all, what kind of a function is that? Notice we've got a very large division bar going on. So I think this is a rational function, as we would often call it, or some books, right, rational. Oops, some bad spelling there. Let me try rewriting that. Rational function. Again, it's technically f of x is equal to 1 over x, the very basic 1 over x function. Again, some books may call that a reciprocal function. Looks like the reciprocal of basic multiplication, right? It's a fraction. So a rational or a reciprocal function. Now, the big difference, again, is that we've added 3. But now notice we've added that inside of my fraction. Technically, order of operations says that addition is going to happen before we divide. And remember, when things happen before the parent function does, then they're going to happen horizontally. So if I had to identify this function, I'm going to say that this is a horizontal. Okay? And because we're adding, it's going to be a shift. But because we were adding, again, it's horizontal. Addition, remember, always takes us to the left. Backwards is what we would normally think, right? Addition, my mind says positive. But again, that means we're going to the left 3 units. And again, if you tried some points, such as on our red function here, notice how 1 gave us back a point at 1. Well, now in order to get that same exact thing to happen, I'm going to have to start over here at -2, 3 units to the left of where I used to be. -2 plus 3 would have been 1, and 1 divided by 1 is 1 over here now. Once we know that we're shifting it to the left 3 units, the easiest thing to do for a rational function is actually think about the asymptotes there. They would have normally been through the y-axis and the x-axis. So what used to be the y-axis, I'm going to shift over 1, 2, 3 units. I'm going to draw a vertical asymptote, right? I was using a dashed line because it doesn't really exist. Again, the horizontal asymptote, the x-axis, if you shift it left 3 units, really isn't going to look any different. But now I know to curve from the asymptote down through my point, and again, curve down toward the other asymptote this direction. And again, don't forget those arrows. And again, the same thing. I would have been at -1, -1. We're left 3 units. So now I'm at -4, -1. And again, I'm going to shift all of my points, my entire arc there, right, or my entire branch of my hyperbola. Everything was shifted to the left 3 units. Right? This point at 1/2, 2 just became a point at -3.5, 2. Right? Or sorry, 2.5, 2. Right there. All right, I hope that helps you with a few transformations. Again, feel free to watch some more videos. I'll make a couple more examples and see if they don't help you with maybe some stretching, some shrinking, or maybe even some reflecting. Have a great day.